Write a program to... Hello everybody, today I'm going to be showing you how to write a program to count iterations for the Collatz conjecture in both C++ and assembly language. So, what is the Collatz conjecture? The Collatz conjecture is a mathematical theory which is named after Lothar Collatz, who introduced the idea in 1937, and the conjecture states that if you start with any positive whole number greater than 1, then if the number is odd, you multiply by 3 and add 1. But if the number is even, you divide by 2. And after a certain number of iterations, you will always end up at 1, regardless of the starting value. So, this program we're going to write will count the number of iterations it takes to reach 1 from any starting value greater than 1 using the Collatz process. So first, let's start with some boilerplates. So include IO stream and type using namespace std, and then we're going to do the for declaration for the assembly function. So extern c, it'll return an integer. We'll call it Collatz ASM, and it'll take an unsigned int starting value. And the C++ function return an int. We called Collatz CPP. It'll also take an unsigned int starting value. Then in the main function, we'll see out CPP C++ returned. Call the Collatz CPP, and then we'll use 25 just as an example. And L, C out ASM returned Collatz ASM 25 and L. cin.get and return a 0. So now we're going to write the Collatz CPP function. So how do you do this? First off, you need an integer to count the iterations. We'll say int iterations equals 0. And then first thing we're going to do is we're going to check to see if the starting value that is passed is actually greater than 1. So we'll say if starting value is less than or equal to 1, we'll just return 0. However, if the starting value is greater than 1, then we'll say while starting value is greater than 1. So what this means is this while loop will keep running until the starting value is less than or equal to 1. Now there's two checks that you need to do. The first one is and that is or it's actually one check, but what you need to do is you need to check to see if the number is even. So we'll say if starting value modulo 2 is equal to 0, and what modulo means is it just gets the remainder of a division. So starting value modulo 2 equals 0, which means the number is even, and we'll do starting value divided equals 2, which basically just sets the starting value to itself divided by 2. Else, if the number is odd, then we'll say starting value times equals 3, which sets the starting value to itself multiplied by 3, and starting value plus plus. And that increments by 1. At the very end, we will do iterations plus plus. And then at the end of the function, we will return iterations. So let's see what we get when we run this. And we got errors, and that is because in the assembly file we need an end directive. So just put that in there. Still have errors. Okay, unresolved external symbol Collatz asm reference and function in the main. Well, a quick fix for that. We'll just comment this out. More build errors. So, just comment that out as well. So, let's see. Right here we get the output of the program. So the C++ function is the only one that's run so far. So we get CPP return 23, meaning it took, starting at 25, it took 23 iterations to get to 1 using the Collatz process. Okay. So now let's write the same function but in assembly language. So I've already included the build customization for MASM. If you don't know how to do that, then just right click on your project, go to build dependencies, build customizations, just click the checkbox next to MASM and click OK. And so we'll write some boilerplate for this. So .code and Collatz asm is a proc, this means procedure, rect return, Collatz asm and p, and we already have an end directive. So what do you do here? So the return value in assembly will be the value that is stored in EAX. So first thing we're going to do is want to XOR EAX with itself. And what this does is it sets EAX register to 0. So it just completely zeroes out any value that is stored in EAX. So then what we're going to do is so now what we're going to do is basically the equivalent of this check right here. And what we're going to do is we're going to compare ECX, which is what the first parameter is stored in through the C calling convention. So compare this to 1, and we will jump if it is compare ECX to 1, we'll jump if it's less than or equal to the n. Let's to finish. And we'll just have a label here that says finish. And what we'll do is we'll just this new return. Other than that, if it gets past that, we'll enter the main loop, which is basically be the equivalent of the while loop right here. So, what do we want to do? So, the first thing you want to do is you want to move EDX, ECX. And basically what this does is it copies the value of ECX into EDX. And the reason we're going to do this is we're going to say IMUL EDX by 3 and inc EDX. So value of 3x plus 1 is stored in EDX. So then what we're going to do with ECX, we'll just shift right ECX by 1. This is value of x by 2 is stored in ECX. And then, so then you're going to CMOV C, which is conditionally move if the carry flag is set, which means that if the number stored in ECX was odd, then the carry flag is going to be set because you would have shifted the 1 out of, you would have shifted the 1 like on the end of the value into the carry flag. So we will CMOV C into ECX, the value stored in EDX. This is what happens if the, which is what happens when if the number is odd. So both of these happen at the same time. If the number is even and the carry flag doesn't get set, it'll actually skip over this. Then what we'll do is we will increment EAX, and then we'll do the equivalent of this check right here. So we will compare ECX to 1. Actually, if ECX was odd, is it copy the value of EDX? Increment iterations. And we'll compare ECX to 1, and we will jump if it is greater than back to the main loop. So now we just about got an assembly version of this function right here. So hopefully when I run this, it will return the same value. And look at that, it does. So you can see the C++ function return 23, and the ASM function also return 23 because we're both passing the same value. Right. So, I hope you found this little tutorial / explanation to be interesting. The source code or the source files will be posted on GitHub if you want to download them and kind of add them to your own Visual Studio solution and play with them yourself. Otherwise, I will see you next time.